Good evening, students. Welcome to the compiler design class. Today we are going to see how to convert from regular expression to NFA. Before going to this conversion, you should know what is an NFA, what is an regular expression. Okay. What is finite automata? Finite automata is the simplest machine which is used to recognize the patterns. It consists the finite set of states, input symbol, initial state and final state, and transition function. The types of finite automata is DFA, NFA. Deterministic finite automata, non-deterministic finite automata. What is non-deterministic finite automata? Here the null move is allowed. Ability to transmit to many number of states for a particular input. That is, NFA can have a 0, one or more than one move from a given state on a given input symbol. And NFA can also have null moves. That is, moves without input symbol. Say this, null moves can have 0, one or more than one move from a given state on a given input symbol. It contains the set of states like Q0, Q1, Q2, alphabets like A, B, transition function, initial state Q0 like this, final state F. So this is an example. In NFA, if any path for an input string leads to the final state, here this is the starting state, double ring shows the final state. For example, in this NFA, there are multiple paths for input string 0, 0. Since one of the path leads the final state, 0, 0 is accepted by NFA. We are going to see how to accept a language for NFA in detail in the next class. What is DFA? It is also contain a set of states, input symbol, initial state and final state, transition function. This is the example. See, here there is no epsilon. For a particular input character, the machine goes to one state only. A transition function is defined on every state for every input symbol. In DFA, null move is not allowed. This is the main difference between NFA and DFA. DFA cannot change the state without any input character. Here, in DFA, the language 0, 1 accepts all the string. It should end with 0. We are going to see the calculation in the next class in detail. Today we are going to see the introduction only. So this is DFA and NFA. Here see, epsilon is allowed in the DFA. More than one state is allowed in NFA. There is no epsilon in DFA. Only one state is allowed in DFA. So far, we saw what are the types of finite automata, DFA, NFA. In DFA, there is no epsilon. In NFA, there is an epsilon. Transition is there. Here only one state is accepted, more than one is accepted. Example we saw. In DFA, deterministic finite automata, no epsilon. NFA, there is an epsilon transition. Only one state is allowed. Here more than one is allowed. Now we are going to see what is a regular expression. Then only we can calculate how to convert from regular expression to NFA. Regular expressions are a notation to represent lexeme's pattern for a token. They are used to represent the language for lexical analyzer. They assist in finding the type of token that accounts for a particular lexeme. Regular expressions are a combination of input symbols and language operator such as union, concatenation and closure. It can be used to describe the identifier for the language. The identifier is a collection of letters, digits and underscore which must begin with a letter. Hence, the regular expression for an identifier can be given by letter, underscore, letter or digit, closure. very important. The definition and rules. R1 plus R2. That is R1 and regular expression plus signifies union. R1 dot R2. It is concatenation, closure. These are the three rules of the regular expression. This table simply explain or is a language, or slash is, that is union, or dot is concatenation, closure to the power. This diagram shows how to draw this NFA. Only one state A, only one state here, dot S dot T. In this way we can dot. There is a concatenation. This is union, S or T. This is closure to the power. See, in this example we can see clearly A, B. How to draw the A dot B concatenation, the NFA. You can straight away 0 to 1 state with labeled A, 1 to 2 state labeled with B. With epsilon it is also possible. A plus B, 1 to 2 A, 3 to 4 B, and plus the concatenation. You have to include one more state in the front and the beginning with the epsilon. Closure A, 1 to 2 the symbol A, and the closure 0 first state, 3 is the last state. So we are having the connectivity from starting to ending, 0 to 3 and 2 to 1. In this way we have to convert our regular expression into NFA. Another example, A or B. This diagram shows A or B union, the closure. We know that we have to include first and last state. There is a transition between initial state to final state and before state to this state. There is 6 to 1. We have to extend A star, B star, extend A. The last state is 7 to 8 extended with the A. This is the last one, so double circle. Okay, hope you can understand with this how to convert from regular expression to NFA. Once again I am repeating, A, B, regular expression. We can draw this NFA. State indicate A, B, epsilon is allowed, union, concatenation, union, closure. In this way we can convert from regular expression to NFA. Hope you can see. The next class we can see more examples in detail, students. Okay. I am Dr. R. Vidya, Assistant Professor, working in St. Joseph's College of Arts and Science, Kannur. Thank you.